Hi, in this lesson, we'll be looking at geometric series, or we call it geometric sequences. What are geometric sequences? Geometric sequences basically are a sequence of numbers where a term and the preceding number have a common ratio. Or I say a term and its preceding number have a constant ratio. We'll use this example to understand how to solve questions with geometric series or sequences. That said, let's get started. Now, like I said initially, a geometric series, if I have a series, probably I say Sn is equals to T1, T2, T3, and it continues in the series up to Tn. For a geometric series, my T2 over T1 will be equals to R. It's unlike the arithmetic progression where we have a common difference, where we've said T2 minus T1 is equals to D. In case you missed our lesson on arithmetic progression, we'll place a link in the description below to help you access our training on arithmetic progression. Same way, in case you are new to our channel and this is the first time you are meeting our channel, do not hesitate to hit the subscribe button. That way you'll be sure to get notified anytime we create lessons as this. That said, if R is equals to T2 over T1, R is also equals to T3 over T2. That is, if T2 over T1 is equals to R, this implies that T2 is equals to R by T1. At the same time, T3 also will be equals to R by T2. Now look at it this way. If T1, let's call T1, if T2 is equals to R by T1, then T3 is equals to R by T2 here. In place of T2, I can still substitute this same expression. That is equals to R. T2 is the same thing as, that's R by T1. Then T4 will be equals to R by T3, that's R by R, that's R squared into T1. That means T2 is equals to R T1, T3 is equals to R squared T1, T4 is equals to R raised to power 3 T1. In most equations, you'll see the first term of a geometric series being referred to as A. So in place of T1, I want to replace with A to form our usual sequence. Now T2 is equals to AR, T3 is equals to, in place of T1 again, I'm putting AR squared, T4 is equals to AR raised to power 3. It continues this way till you come to Tn. If you look closely, you see that the difference between my n is 4, and R is raised to power what? That's R raised to power n minus 1. So for your geometric progression or geometric series, we can conclude that our Tn is equals to AR raised to power n minus 1. Let's get started with our example. Our example says the second term of an arithmetic progression the second term of an exponential sequence, that's T2, is equals to 35. And remember that second term is the same thing as AR. And the fourth term of the arithmetic progression, T4, is equals to 875, which is the same thing as AR raised to power 3. Let's call this our equation 1, and let's call this our equation 2. We have to find the first term of this series, that's A. Now, let's divide equation 1 by equation 2, such that 35 over 875 will be the same thing as AR over AR raised to power 3. A here will be 1, A here will be 1, R here is 1, R here I will be left with 2. So that my 35, now let's divide my 35 over 875 is equals to 1 over R squared, which implies that, now 5 here is 7. 5 in 8 is 1. I'm left with 3. 5 in 37, that's 7. And 5 in 25, that is 5. 7 here is 1. 7 in 17, that is 2. I'm left with 35. 7 in 35, that is 5. That implies that 1 over 25 is the same thing as 1 over r squared. I can find the square root of both sides since I have 25, which is a multiple of 5. That implies that my 1 over 5 is equals to 1 over r. Now, if 1 over 5 is same as 1 over r, automatically I know that r is equals to 5. Now, remember that 35 is the same thing as AR. That implies that 35 is equals to A into 5. Let's divide both sides by 5. I divide this side also by 5. 5 here is 1, 5 here is 7. So that A now, which is the first term of the sequence, is equals to 7. Now I'm asked to look for the first term. This is the first term of the sequence. The next question is to solve for the fifth term of the sequence. The fifth term of the sequence, that's T5, is equals to AR raised to power 4, which is equals to my A is 7 times my R is 5 raised to power 4. That is 7 times 5 raised to power 4. 5 raised to power 4, that's 25 times 25. That's 625. Now 625 times 7. 625 times 7, that's 5, I have 3, 14, yes, 7, 17, that's 42, yes, 4, 3. So that my solution, my T5, is something as 4, 3, 7, 5. Thank you for staying with us. If you have questions, please do not hesitate to use the comment section. We'll be there to receive your questions. Thank you and do have a nice time.